Good evening everybody and welcome to the vlog for Tuesday, July 11th, 2017. Happy Prime Day! It really says something about our country that Amazon Prime Day is essentially a holiday. Anyhow, today was just another work day for me, and while I do not have anything new to announce to you, I did learn something kinda cool that I thought I'd share with you guys in the form of a small tutorial. But if you do want to stay up to date on the latest and greatest news for my game development project, please hit that subscribe button below. And so today's video is going to deal with the Unity game engine's input system and how there is a minor flaw with it, but that can be overcome with a simple little bit of code. So if you're interested in this tutorial, please stay tuned and be sure to hit that like button if you find this video useful. As always, you can leave me questions in the comments section below. And with that, let's get on with the tutorial. Alright, so I'm just going to give you guys a quick overview on Unity's main problem with inputs, which is specifically related to dead zones. And so before I get into it, I'm going to explain what a dead zone is and why we need them in video games. So when we want to get input from an analog stick on a controller, such as this one, the input for each axis is tracked on a variable that ranges from -1 to 1. So for the x-axis, -1 is for pushing the stick all the way to the left, and +1 for pushing it all the way to the right, and 0 for its center resting position. And same thing for the y-axis. -1 for pushing the stick all the way down, and +1 for pushing the stick all the way up. So within this circle is every possible input you can have for that analog stick. And so I have this red circle in the middle that represents a dead zone. And within this dead zone, no input is tracked. And the reason we do this is because analog sticks can kind of wear out over time. So even when we have them sitting just like this, the stick may not be perfectly centered, and it'll actually be giving a slight amount of input in one direction. And for this reason, sometimes you'll see games where the camera or a player is moving ever so slightly, even when you have the controller sitting on the table. So again, that's because the computer is receiving a signal from the controller saying that it is inputting in one direction or another, even though your finger isn't on the stick at all. So some programmers came up with the solution of putting a dead zone in, which is a small little area on this grid where no input is detected. So even if your stick is slightly to one side or another, it won't matter, and the computer will just think that it's at 0, 0. And now I'll take a minute to describe the problem with Unity specifically. So you see here for the input axes, there actually are values for dead zones already. And by default, when you make a new joystick axis, this value is set to 0.19, which seems pretty reasonable. But the issue is that this is the dead zone for only that axis, as opposed to some sort of combination of both axes. And so I have a little diagram for you to explain what exactly is happening. So this actually sort of creates two different dead zones in a cross-like pattern. And so I just put in a couple little dotted lines to help you visualize my point a little bit better. So the issue is, say if you're to push the stick all the way to the right. So when they do that, no input will be detected up until the input is at this point right here. And anything past this point, the computer will start detecting input. And so if we push the stick all the way to the right, the input will be all the way to the right, which is exactly what we want. But if we were to start to push upwards slightly, you'll actually notice that it's still in the dead zone for the vertical axes. And so if you were to put in this angle right here, the input should be slightly upwards like this, but actually just snaps to the horizontal axis. And I was starting to notice this in my game a little bit, where the input when I was trying to aim, it was snapping to the directions left, right, up, and down. And I was having trouble figuring out why exactly it was doing that, but then I came across this article today, which I'll link to in the description below, that details this issue and how to resolve it. And so there are a couple solutions, but this one is the easiest and it works best for my particular game. So basically we'll turn off Unity's built-in dead zone and then create this little ring dead zone through code, which is super simple and it will lead to much smoother input. Alright, so first I'm going to display to you the erroneous behavior that occurs when you use Unity's dead zones. And so temporarily I've just cranked these values up to 0.5, so the behavior is a little more noticeable, but it's definitely still there when you have it at 0.19, which is the default. So here you'll see that as I rotate the stick smoothly, this beam that I have tracking the input will snap to the directions up, right, down, and left because of the dead zones that Unity has. And you'll see that I can actually wiggle the joystick around, and the beam only moves when I go past halfway one direction or the other, and same thing along the horizontal axis. Okay, so here I just have a simple script that I'm going to use to show how you get around the dead zone issues with Unity. So I just have a public float variable for the left stick dead zone, so we can set that to whatever we want in the editor. And I also have a public game object for the laser, which will give us a visual representation of the input from the left stick. And I also have a local vector2 variable for the input force. So in the update function, which is called every frame, the first thing we're going to want to do is obtain input from the player. And this is just a little tip for game development in general. The first thing you should always do from your main update function is get input from the player. You want to get this before you do anything else in your code. So we'll just set the input force equal to a new vector2 that is made from the horizontal and vertical input from our left stick. Now, this is the actual block of code where we check to see whether the input is inside or outside of the dead zone. And so all we need to do is check the input force's magnitude, and if it is less than our left stick dead zone variable, we just clamp the input force to 0. And so the rest of this code basically just sets the angle of our laser beam so we can have a good visual representation on that. So feel free to read through that if you're interested. So within the Unity input manager, we just want to set the dead zones on the horizontal and vertical axes to 0. And so that way we won't have these variables messing with our game at all. So I just have a empty game object called scene controller with my vlog script on it. And so we can just set the left stick's dead zone to that same value of 0.19. And I also have a game object which I called laser, which just has a line renderer on it, so we can get this nice cool little beam, and we'll drag that over into our laser object here. And so now when we hit play and we pick up the controller, we can see that it is no longer clamping to the up, right, down, and left directions, and we get nice smooth input all around. So now I can really demonstrate how this dead zone works if I say put this value to 0.9. So when we go and hit play, you can see that I'm moving the stick around, and it's really only getting input when I'm pretty much at the edge here. Anything in the middle is all within the dead zone. So we can put this to a more realistic value of like 0.05, and you can see that it's not getting any input when it's just sitting here. But when we even put the slightest little bit of input on, we can now move the beam in any direction that we want to. And so that's going to conclude my little tutorial on Unity's dead zones and the issues that come with them. I know this definitely misled me, and there's probably a lot of you out there who didn't even know this was happening. And please do go check out that article that I found. It was extremely useful, and it basically taught me all of this. And it even went a little step further if you want to get really precise input. So if you found this video useful, please give it a thumbs up. Be sure to subscribe to the channel if you haven't already. And if you have any questions for me, leave them down in the comment section below. I hope you all have a great rest of your day. Peace out.